Okay, so how do we breathe is the next part of this chapter. How do we breathe? There are two cavities involved in breathing. Okay, what are the two cavities? One of them is the nasal cavity, and the other is the chest cavity. Okay, now in this nasal cavity, we bloody have the nose only. Okay, and the chest cavity consists of, and the chest cavity consists of lungs and the diaphragm. Okay. Okay, diaphragm, people remember it as, because if they have any spelling mistake, they don't want to do that. So diaphragm or diaphragm, and the nose is consisting of the nose, nostrils, the nose part itself, nasal cavity is there. Okay, so what usually happens, the air enters from the nasal cavity, okay, from the nostrils, and it goes into your windpipe. Okay, there's something called as a windpipe. Okay, now going, what is the name of this windpipe actually? If we say the name of the no, the windpipe is the trachea. What is it? It is the trachea is there. Okay, now so let's name it. This is the trachea. Okay, trachea is the name of it. Now this trachea, okay, is going to divide itself into two parts. Okay, it is dividing. This is a tube, which is a cartilaginous tube. Okay, and it is made up of a cartilage. Okay, so it is a cartilaginous tube that is there. Okay, and it gets divided into two parts, two tubes, which are called as the bronchi. Okay, bronchi. Okay, and on each bronchi a lung is connected. Okay, so the lungs are connected on each side of your bronchi. Okay, this is the shape of your lungs. Now the right lung, I told you that the right lung is going to be slightly larger in shape. It's larger in shape when you compare to your left lung. Okay, why is your left lung smaller in size? Because the left lung is accommodating your heart, and to give the heart the space, okay, to be accommodated, the left lung is a bit smaller in size when compared to your right lung. Okay, this is how your lungs in this thing looks. Okay, now going further, this is your right lung and this is your left lung. Okay, now people will name it this as the left lung and this as the right lung. No, because when they operated a human body, how did they operate the human body? They operated the human was lying like this. Okay, and probably his body was like this. Okay, so they cut open his body and they saw the heart, and they didn't take out the heart, put it down on the piece of paper, and then label it. They saw the heart in the human body itself and they made a picture of the heart of however it is. So the lungs also, when we are drawing the lungs from the nasal cavity which is coming, it is getting divided into the bronchioles, and the lungs are placed like this in the body, right? So the same way, the same picture was made on the paper. Okay, and then if this was the right lung, it is named as the right lung, and this is the left lung of this human, so it is named as the left lung. Okay, this is about your left and the right lungs ka description, why they are not taken like this. Okay, now so going further ahead and understanding what is going to happen now, we are aware of this, that when you inhale, whenever there is a process of inhalation is breathing in. Okay, when you breathe in, what's going to happen, the lungs will expand, lungs are going to expand. Okay, and for the expansion of the lungs there needs to be some space. Why is the space required? Because the lungs are expanding full capacity, they want to expand. So when the lungs are going to expand, they need to have a full capacity. And to where is the space going to come from? There is a certain organ just underneath your lungs. There is a very certain organ underneath your lungs which is called as the diaphragm. Okay, and this diaphragm is going to contract. This diaphragm, it's in a normal or relaxed pattern, it's going to be like this. Okay, it is going to be in this particular shape. This is the normal shape. So when it is going to contract, okay, it is going to contract. Why is it going to contract? So to give the space for the lungs to expand. Okay, so when it contract, it becomes like this. It is going to shrink down. This will be pushed down. Okay, and it becomes like this. The diaphragm becomes like this, okay? And when you exhale, what's going to happen? When you exhale, the lungs are going to contract. There is a contraction of the lungs, okay? They're going to squeeze back, and when they squeeze back, the diaphragm will come back to its original shape, and it will expand to its original. From here it is going to go back to its original, what do you say, whatsoever it is, okay? That's how the expansion is done for mm for the particular diaphragm, and how the space is being provided for the lungs to expand. So the diaphragm and the lungs, they are coordinating with each other to allow the intake of gases, okay? Exhaling is breathing out, okay? So this is how the basic breathing takes place, okay? So when you take a deep breathe in and you keep your hand on your abdomen, you will feel that the abdomen and everything part is going to uh, become bulge out of your body, right? That is because the diaphragm is contracting, and again your lungs are expanding, okay? So there's this is how the thing is going to take place in our body, okay? Now, the people who smoke, their lungs do not have the ability to expand and contract completely, okay? The lungs are damaged. And why are they damaged? Because they are constantly not getting enough amounts of oxygen, which is leading to it, okay? It is which is leading to it, and this is going to cause the and this is what is going to cause them whatever the side effects are there. So here it is shown, a picture is shown for your inhalation and exhalation. This is the normal diaphragm, it is supposed to be, okay? And it starts to move in when you are breathing in. The air is drawn inside, that means air is entering, the lungs are going to expand, and this diaphragm has to come down, okay? And when you're forcing out the air, the lungs are going to shrink back in, or they're going to contract, and the diaphragm is going to go back to its normal position, which is the expanded position of it. So this is the figure for your inhalation and your exhalation, okay? Leave this table 10.2 over here. And then now there is another experiment that they are doing over here. What they are taking is, they are inserting they are taking, what is that, yeah, they're taking a pipe which is being cut into two parts, okay? They're creating kind of like the windpipe, or the trachea and the bronchi they are creating, and they are having two balloons attached to it. So what's going to happen when you blow the air in? What's going to happen? This particular thing, okay, is going to fill with air, and it's going to expand. And when you pull the air out, it will shrink back, and it will become like this. How the diaphragm is working, what is the action of the diaphragm, that is studied by taking an open end container. This container does not have an open end. Instead, a rubber balloon has been attached to the bottom of it. So what's going to happen is, when you are filling air in this two balloons, the air from this container gets pushed into this rubber balloon, and it bends downwards, okay? So the diaphragm is bending downwards, isn't it, from its original position, right? That's how it is showing. When these balloons are getting bulged, the air is pushed, the air in the container is pushing this rubber thing, and it will bend down. And when you exhale it out, that means this air is getting out. So what is going to happen? The air from here also can come back into the container, and it becomes a straight hollow rubber sheet, okay? So this is how the expansion and the functioning of the diaphragm has been explained by the help of the balloons and the straws and whatsoever it is, okay? Now, there's something called as when you okay, when you are exhaling air for a quite long time, you appear to see that there's some moisture in the air, okay? Where are these droplets of water coming from is now what we are going to see in the video, okay? When you're constantly blowing air into the straw, or you take your hand, you keep on blowing. Now where is this coming from? What do you see some droplets of water, or you see some saliva in it? Why is that happening, and where is it coming from, is the next thing that we are supposed to consider, Okay, the air in our body which is coming out is warm air, and whenever there is warm air, what's going to happen, this warm air is going to this warm air is going to, what do I say, um, is going to contain some water vapors from our body and stuff, right? That water vapors is coming out from our, through our nose, from our lungs, through our nose, and they get collected in the straw or wherever you are blowing it. Sometimes you, especially during the winters, when you go near a glass and you blow on the glass, you see some fog of some kind of mist getting deposited on it, right? So that is because of the water vapors evaporated due to the internal heat of the body, which have been evaporated, which got mixed up with the air, and they are getting expelled out of it. Okay, yeah. Now the percentage of oxygen, carbon dioxide in the inhaled and the exhaled air. The inhaled air is having more amount of oxygen because that's the normal air that we are taking in. 21% oxygen is entering, 0.04 carbon dioxide is entering. Whereas the exhaled air is having oxygen as well as carbon dioxide. This is one of the biggest ghatia thing that has been taught to us, that we inhale oxygen and give out carbon dioxide, but whereas it is completely wrong. Why? Because we are taking both carbon dioxide and oxygen, and carbon dioxide and oxygen are given out as well. So 16%, 16.4 percent of oxygen will be there in it. When compared to 0.04, 4.4 is a much bigger value. So the carbon dioxide content is more in the air that we breathe out. This is how the humans breathe. This is the explanation for the first part.